Hi everybody. So in this video we're going to continue with chapter 1, Algebra and Function Basics. And specifically we're going to go into topic 1.3, Composition of Functions. So here we are with example 1.18, and it says, if f of x equals 3x and g of x is equal to 2x minus 6, find part A, f of g of 5. So another way to look at this is with this other notation that means the same thing. We can write this as f of g of 5. So what this implies is that we plug in 5 in g of x, and then the result of that we would plug in f of x. So let's do g of 5. So g of 5 is simply going to be 2 times 5 minus 6, and this equals 4. So now we need to plug in 4 in f of x. So f of 4 is going to equal 3 times 4, which is 12. So this would be part 1. For part 2, they're asking us to express it as a single function rule. In other words, let's do it algebraically and get a final equation. So if we have f of g of x, this implies plugging in g inside of f, right? So g of x is 2x minus 6, and f of x, which is the outer function, is 3 times x, so 3 times g of x, right? And this is going to equal 6x minus 18. So notice that if I do now f of g of 5 directly into this function, f of g of 5, it's going to give me 6 times 5, 30, minus 18, 12. So I arrive to the same answer, but in one step. So in the next slide, we have the continuation, and we go with part B. So now they want us to do the opposite, right? Now it's g of f of 5. So for B, what they want us to do is plug in f of 5 first. So f of 5 is going to equal 3 times 5. That's going to be 15. And then this we have to plug into g. So it would be 2. Well, actually, I should write the notation. So it's going to be g of 15, which is equal to 2 times 15 minus 6. And this is going to equal 24. Now they want us to do the same thing, but using it as a single function or creating the single function, right? So this would be g of f of x, meaning plug in f inside g, right? So this would be 2 times, instead of x, we write 3x, 2 times 3x minus 6, and this is going to be 6x minus 6. Notice that if we plug in 5 directly here, we're going to get also 24. So now let's focus on part C. And notice that for number 1, it says, what is g of 5? What is g of 5? So that implies plugging in 5 in g of x, and then whatever we get from that, plug it again into g of x. So this would be g of 5 is equal to 2 times 5 minus 6, and this is going to equal 4. So what's g of 4? G of 4 is going to be 2 times 4 minus 6, and this is going to equal 2. So now let's express g of x as a single function. So that's going to be g of x is going to equal 2 times 2x minus 6 minus 6. So this will then be 4x minus 12 minus 6, which is 4x minus 18. So now notice that what happens if we plug in 5 in here? Well, we're also going to get 2. So next we have example 1.19, and it says, given the function f such that x maps into 3x minus 6, and the function g such that x maps into 1/3 x plus 2, find a f of g of x. So for a, we do f of g of x, but recall that that is the same as just plugging g of x in f of x. So f of x is the outer function, so it would be 3 times g of x, which is 1/3 x, 1/3 x plus 2, and this minus 6. So this is going to equal 3 times x divided by 3, that's just going to be x, and then 3 times 2, that's going to be 6, minus 6, and this equals x. So notice that we get x, the identity function. For b, we're going to do g of f of x. So it's backwards. Now we're going to introduce f of x inside g of x. So it's going to be 1/3 times 3x minus 6 plus 2. So in this case, we're going to get x minus 2 plus 2, and this also equals x, the identity function. So why is that? Why is it that g of f of x equals f of g of x, and they both equal x? Well, the reason for that is that this is actually a test for something that is called inverse functions. That means that f and g are the inverse to each other, and when that is the case, by doing the composition of g of f of x and f of g of x and getting the result of x in both cases is a proof that they are the inverse of each other. The next slide talks about decomposing a function. So decomposing a composite function. An example 1.20, and it says each of these functions is a composite function of the form f of g of x. For each, find the two component functions f and g. So remember that f is the exterior function and g is the interior function, at least in this case. So for a, it's easy to see that f of x is the reciprocal. So we can describe it as 1/x, whereas g of x would be the linear function x plus 3. For b, because it's an exponential, we can say that f of x is 2 to the power of x, the outside function, and the inner function g of x would be the also linear 4x plus 1. And finally c, f of x, the outer function, would be cubic root of x, and g of x, the inner function, would be x squared minus 4. Very well, so now we are in example 1.21, which will be the last one on this video. So it says, let g of x equal x squared minus 4, and h of x equal square root of x. Find a g of h of x and its domain and range. So let's start with g of h of x. So this would be, again, plugging in h inside g of x, and that's going to be square root of x squared minus 4. And this will equal x minus 4. Okay, so now it's domain and range, and you have to be careful because if you base your answer on the resulting function, it's going to be wrong in this case. Notice that x minus 4 has a domain that is all real numbers and a range that is all real numbers. Or you can also say from negative infinity to positive infinity. But because it's a composite function, we have to take into account h of x. So we can use this here to see what the domain and range are. So h of x, which is square root of x, is going to limit the domain. The domain will be x values that are greater or equal to 0. That is the domain because we cannot have negative square roots. Then the range would be the result of plugging in values in this function. You can take the last one. You can take this one. 4 values that are greater or equal to 0. So notice that the lowest value would be negative 4 and after that it'll just keep increasing to infinity. Therefore, the range would be y greater than or equal to -4. So now let's do it the other way around, where they ask h of g of x. So here we plug g of x inside of h of x. So we're going to get x squared, or the square root, I should say, of x squared minus 4. So what would be the domain? Well, the domain is restricted by g of x, and also the fact that we have a square root. So because we have a square root, it means that x squared minus 4 must be greater than or equal to 0. So because this is quadratic, we have to express it like this: x minus 2 times x plus 2, greater than or equal to 0. And we're going to get critical points of 2 and -2. So I'm going to write a table of values, -2 and 2. These are the critical points because those are the values that will make this equal to 0, right? But we also have to see where it is greater than 0. So what happens when we have a number that is lower than -2, right? Because we have to consider what happens between -infinity and -2. So we can just plug in -3 or anything that is lower than -2. Notice that if we plug in -3, we're going to get 9 minus 4, and that's square root of 5, a positive value. So what happens between -2 and 2? Let's plug in a value, say, that is between these, like 0. So notice that if you plug in 0, 0 minus 4 would be -4, and that is undefined, right? In the case of the square root, it's going to be a negative. And after 2, because this is squared, it's going to be the same as plugging in -3 if we plug in 3. So it's also going to be square root of 5, which is positive. And obviously for anything greater than that, greater than 2, we're going to get positives. So that means the domain would be x values that are less than or equal to -2, and x values that are greater than or equal to 2. Then the range is easy to determine because this is a square root and this is infinite, and so is this. If you go in this direction, you get infinite. In this direction, you get infinite results as well, but they're all going to be positive. So the lowest value is going to be 0. Therefore, the range would be all values of y greater than or equal to 0.